So what we're going to look at next has to do with what's known as a complex number. And some of the different areas that you've seen a complex number have been when using the quadratic formula that has a discriminant that's negative. So a couple different things about complex numbers. First is just referring to what's known as the imaginary unit. So when you have the imaginary unit, which we're going to call I, and I equals the square root of -1, and I squared equals -1, and that is a part of some of the different things that we're going to look at with complex numbers. So a complex number basically combines a real number with some sort of imaginary component in some sort of sum or difference. So the standard form of a complex number is of the form a plus bi, where a is the real part of the complex number, that's a real number, and the b times I part is the imaginary piece to the complex number. So one of the things that we're going to sort of investigate first is some different things that we can do with the imaginary unit. So even though the imaginary unit is an actual value, we're going to sort of use I to represent what the imaginary unit is. So when we're talking about operations with complex numbers, we're going to treat the imaginary unit, we're going to treat I as if it were a variable, but just remember that it's not a variable because its value is always the square root of -1. So, for instance, if I add 3i plus 4i, that would equal 7i. So I'm treating it just like it were a variable, even though it actually isn't. Or if you had something like this here, if I combine like terms here, 5 plus 3 would be 8, and then 2i plus -i would be positive I. Such just some different things involving sums. As far as differences go, same kind of thing. If I did 3i minus 4i, that would be just -i or -1i. And if I did something like this, where if I had two complex numbers to subtract, if I did 5 minus 3, that's positive 2. And if I did 2i minus I, that would be plus 3i. So just some different things there with sums and differences. But we can also do some different things with products, which we'll look at in a moment here. But in terms of just adding and subtracting, if you take a look at part A, I'm going to basically take this complex number and add it to this complex number here. So to do that, first I'm going to do 4 plus 1, which is 5. And then I'm going to add 7i plus -6i, which would just be plus I. So you get something like that there. And then for part B, I'm going to do some subtracting. So for here, I'm going to do 1 minus 4, which is -3. And then I'm going to do 2 minus 2i, which if you notice, they cancel each other out. And I'm just left with a -3 here. So just keep in mind with some different things with adding and subtracting that sometimes you can have either a real part that cancels itself out and you're left with just an imaginary piece, or as in part B, you can have your imaginary pieces cancel each other out and you're just left with a real part. But just notice the standard form, particularly for part A here, that we wrote this in, the real number plus the imaginary part that's at the end. So one of the things that you can do with your calculator to check to see if you're right with this is if you go to your calculator and you just type in what the question says. So for instance, part A, if I did 4 plus 7i. So just keep in mind, if you look down here at the bottom of your calculator in blue, you have the imaginary unit above the decimal point. So if I push second decimal point, that's going to get the imaginary unit to come up. Plus, this would be 1 minus 6i. So I could just type that in, and when I do that, it's going to give me the answer in standard form. So just something you can do with your calculators when you get to the end to check to see if your answers are correct. So kind of a nice thing there as far as that goes. So with the next two parts, just once again, I'm still just doing sums and differences here. So I'm going to take for part C, I'm going to do the real components here first. So just remember, this negative gets distributed to the parentheses. So this ends up really being positive 2 minus 2, which ends up canceling out there. And when I do 3i minus 3i, that also cancels out there. And then this negative would get distributed to that positive 5i, which would just make the answer to this negative 5i. So there's an example where the real part cancels out and you're just left with an imaginary part there at the end. Same kind of thing for part D. If I put my reals together, this would be 3 plus 4 is 7, minus 7 would be 0. So the reals cancel out here. And then if I take my imaginary parts, 2 plus negative I would be positive I, and then I minus I would be 0. That would cancel out. So the answer to this, because both pieces cancel out, the answer to this would just be 0. So that's just some different things with part D there. So just one thing to note, that in part B and part D, that the sum of two complex numbers can actually be a real number. So for instance, 0 here is a real number, and in part B, because the imaginary part canceled out there as well, you get a real number answer when you simplify the complex number. So some different things just want to kind of show you here as far as a pattern goes. So just taking a look at just filling in some blanks here. So I have I to the first is just the square root of negative 1, and then I squared is just negative 1. And then I cubed I could get by doing I squared times I. So if I did negative 1 times the square root of negative 1, I would just get negative square root of negative 1, something like that there. And then I to the fourth I could get from doing I squared times I squared, which would just be negative 1 times negative 1, and that's positive 1. So just some different things there as far as a pattern goes. Now just let me kind of go to the next column here, and I think you guys will see kind of something interesting. So I to the fifth I could get from doing I times I to the fourth. And when I do I times I to the fourth, I'm doing 1 times the square root of negative 1, which would just be the square root of negative 1. My negative in there. And then I to the sixth, I could get I to the sixth from simply just doing I to the fourth times I squared. So I to the fourth is positive 1, I squared is negative 1, and when I multiply those together, I get negative 1. I to the seventh, I could get I to the seventh from simply just doing I to the sixth times I, which would be like doing negative 1 times the square root of negative 1, which would just be negative square root of negative 1. And then I to the eighth I could get from simply just doing I to the fourth times I to the fourth. There's a couple different ways to do this, but I think that's probably the easiest. There's I to the fourth. So when I do that, I'm really just doing 1 times 1, which is 1. So hopefully you kind of notice a pattern here. I have square root of negative 1, negative square root of negative 1, and then positive 1. And then when I go to do I to the fifth, the pattern sort of repeats itself. So I to the first and I to the fifth are the same, I squared and I to the sixth are the same, I cubed and I to the seventh are the same, I to the fourth and I to the eighth are the same. So when I go to continue the pattern, I to the ninth would be just the same as I to the first or I to the fifth, which would be the square root of negative 1. I to the 10th would be the same as I squared and I to the 6th, which is just negative 1. I cubed and I to the 7th would have the same answer as I to the 11th, which would be negative square root of negative 1. And then finally, I to the 4th and I to the 8th would have the same answer as I to the 12th, which would just be positive 1. So just want to kind of show you just a little sort of pattern there to what happens when you start to multiply I by itself. So in terms of multiplying, one of the things that we can also do with complex numbers is to multiply them. So just remember, when you're multiplying, you're going to treat I just like you would treat a variable. So with part A, when I go to do this here, I want to distribute the 4, and when I do that, I just get negative 8 plus 12i. So you get something like that there. For part B, I want to FOIL the two complex numbers here. So when I do that, I get positive 8 plus 6i minus 4i, and then this would be minus 3i squared. So when I combine like terms here, I get 8 plus 2i minus 3i squared. So just keep in mind that anytime you can take an imaginary unit and turn it into a real number, you want to make sure you do that. So if I come back to this here, notice I squared is negative 1. So what I want to do to simplify part B, I want to take I squared and I want to substitute a negative 1 in its place. So when I do that, when I multiply negative 3 times negative 1, I get positive 3. And when I combine that with the positive 8, I end up getting 11 plus 2i. So just one sort of thing there with Part B. Don't ever miss the opportunity to take an imaginary number and turn it into a real number whenever you can. So that's Part B. For Part C, same thing. I'm going to FOIL. So I'm going to do 3 times 3 is 9. 3 times negative 2i is negative 6i. When I do the inside, 2i times 3, that's plus 6i. And then when I do the last times the last, 2i times negative 2i is negative 4i squared. So hopefully you notice here that this was a difference of 2 squares, which means my two middle terms are going to cancel out here. And when I do that, I'm left with 9 minus 4i squared. So once again, I squared, I can take this and make it negative 1. And when I do negative 4 times negative 1, that's positive 4. And when I combine that with the 9, I end up getting 13. So that's the answer for Part C there. And then for Part D, remember, this is 3 plus 2i times itself twice. So I got to do this here. And when I do that, I'm going to get 9 plus 6i plus 6i. And this will be plus 4i squared. So when I combine like terms here, this is going to be 9 plus 12i plus 4i squared. But once again, just notice you have this I squared at the end, which I can make negative 1. So when I do positive 4 times negative 1, that's negative 4. And when I combine the negative 4 with the positive 9, that ends up being 5 plus 12i. 5 plus 12i. And that's Part D right there. So some other things that we can do with complex numbers. We can add them, we can subtract them, and as you can see here, we can also do some different things with multiplication. So the other thing we're going to look at in regards to complex numbers is what's known as a complex conjugate. And a complex conjugate is of significant importance when we're talking about trying to remove an imaginary unit from the denominator of a fraction. So remember when we talked about rationalizing denominators, whenever you have a square root in the denominator, you want to rationalize the denominator so that the square root is no longer in the denominator of a fraction. So if you think along those lines, whenever you have an imaginary unit in the denominator of a fraction, what you essentially have is a square root in the denominator of the fraction. So one of the things that we use in order to remove a square root or an imaginary unit from the denominator of a fraction is this whole business of what's called a complex conjugate. So a complex conjugate basically takes a complex number that's of the form a plus bi, and its complex conjugate would be of the form a minus bi. Or if you had a minus bi, its complex conjugate would be a plus bi. So just to give you a for instance, if you had the complex number 2 plus 3i, its complex conjugate would be 2 minus 3i. Or if you had, say, the complex number negative 4 minus I, the complex conjugate of that would be negative 4 plus I. And one of the things that you'll notice that will happen when we do complex conjugates and with multiplication is that the middle terms will cancel each other out, because you essentially end up, when you multiply a complex number by its conjugate, you end up multiplying a difference of 2 squares, which will make the middle term cancel out when you do that. So for example 4, the question says multiply each complex number by its complex conjugate. So with 1 plus I, I'm going to multiply this by 1 minus I. That's its complex conjugate. So when I FOIL that, I got 1 times 1 is 1. I got 1 times negative I is negative I times 1 is positive I. And then I times negative I would be negative I squared. So notice here the two middle terms cancel out, and what I'm left with here is 1 minus, so remember I'm going to make I squared negative 1. So I end up with 1 minus negative 1 which when I combine those, I get an answer of 2. So that's for part A. For part B, I have 4 minus 3i, and the complex conjugate of that would be 4 plus 3i. So when I FOIL this, 4 times 4 is 16, 4 times 3i is positive 12i, negative 3i times 4 is negative 12i, so just notice your middles are going to cancel there. And then when I do negative 3i times positive 3i, I get minus 9i squared there. So the middle terms cancel out again, and what I'm left with here is 16 minus 9i squared. So just remember, I'm going to make I squared equal to negative 1. So when I do negative 9 times negative 1, that's positive 9, and when I combine that with the 16, I get an answer of 25. So that is essentially what happens when you multiply a complex number by its conjugate. You're going to get a real number answer when you do that multiplication there. So in terms of what we use complex conjugates for, and we're going to use them to remove the imaginary unit from the denominator of a fraction. So if you recall when we were talking about rationalizing denominators, so for instance, if you had 2 over the square root of 3, the way I would rationalize the denominator there is I would multiply the fraction by the square root of 3 over the square root of 3. So remember, you can do that because the square root of 3 over the square root of 3 is 1. And anytime you multiply something by 1, the value stays the same. So I'm going to do the same thing here with a complex conjugate. So if you ever have an imaginary unit in the denominator of a fraction, what I want to do to remove that imaginary unit is I want to multiply the fraction by the conjugate of the denominator over the conjugate of the denominator. So just remember, these have to be the same, because when you divide that out, that equals 1, and multiplying something by 1 doesn't change its value. So if you take a look at these two questions here, for part A, I have to write in standard form 2 plus 3i. So just notice I have the imaginary unit in the denominator of the fraction. So when I have 2 over 3i, the complex conjugate of 3i is negative 3i. So I'm going to multiply this fraction by negative 3i over negative 3i. And when I do that, that's going to remove the imaginary unit from the denominator. So just remember, when you're multiplying the fractions, you want to multiply straight across. 2 times negative 3i would be negative 6i. And then 3i times negative 3i would be negative 9i squared. So just remember, this I squared is negative 1. So when I multiply the negative 1 to negative 9, that's positive 9. So I end up with this, negative 6i over 9, and I can reduce 6 over 9 to be 2/3. So this would be negative 2i over 3. So to check your answer to see if you're right here, if I come back to my calculator again, and I put in 2 over 3i, so let me clear this out here and get my fraction key up. So if I put in 2 over 3i, okay, it's not going to let me do that. So let me try it this way. So if I have 2 over 3i, I think I got to put this in parentheses. Let me see if it'll let me do it this way. And if I math frac enter that, so I could get it as the fraction, you'll see you get there negative 2/3 I, which is the same as saying negative 2i over 3. So that's one of the ways you could use your calculator to check your answers for that. So that's part A. For part B, I have 2 plus 3i over 4 minus 2i. So with this here, I'm going to take the original fraction and I'm going to multiply it by the conjugate of the denominator, which is 4 plus 2i, over the conjugate of the denominator. So just remember, to multiply, I'm going to multiply the numerators, I'm going to multiply the denominators, and I have to FOIL this when I do it. So I'm just going to put these in parentheses so it looks a little more like a FOILing problem. So when I FOIL the top, 2 times 4 is 8, 2 times 2i is 4i, 3i times 4 is 12i, so when I put those together I get positive 16i, And then when I multiply 3i times 2i, I get plus 6i squared. So that's what you get when you multiply your numerators. For the denominators, I got 4 times 4 is 16, and then 4 times 2i is 8i. Negative 2i times 4 is negative 8i. That's going to cancel. And then when I do negative 2i times positive 2i, I get negative 8i squared. So if I do some simplifying here, just remember this equals negative 1 and this equals negative 1. So with the numerator, if I do positive 6 times negative 1, that's negative 6. And when I combine that with 8, I get 2 plus 16i. And then with the denominator, when I do negative 8 times negative 1, that's positive 8. And then positive 8 plus the 16 would be 24. So if I break these up, I'm going to get 2 over 24 plus 16i over 24. So here's the thing, 2 reasons I'm going to break this up. One is because both of these fractions can be reduced, but they're reduced in a little bit of a different way. The other thing is that this is the standard form. It's the real number plus the imaginary part. So when I reduce 2 over 24, I get 1 over 12. And when I reduce 16i over 24, I get 2i over 3, or you could call that 2/3 I. So to check to see if I'm right here, if I come back to my calculator, and just be careful when you put this in. So when I take the numerator, I'm going to put this in parentheses. So I'm going to have in parentheses 2 plus 3i. So I got that there. Divided by the denominator in parentheses, 4 minus 2i. And I'm going to mathfrak enter this before I hit enter. So there's the value that you get when you do that. There. So that looks a little bit different than what we got. So let me come back to this again. So let me see here. Let me try this one more time. So when I put my 2 plus 3i over 4 minus 2i, I wonder if I wrote this down wrong. So I'm going to multiply this by 4 plus 2i over 4 plus 2i. So when I FOIL the top, I get 8. This would be plus 4i. This would be plus 12i. So this is plus 16i. And then when I multiply 3i times 2i, I get minus 6i squared. And then when I multiply the denominators, this is 16 times positive 8i and then negative 8i. And then when I do the negative 2i's, I get negative 4i squared there. So now when I put these together, I see what mistake I made here. So I got this is negative 1 and this is negative 1. So let me just make a note of that on the side here. So when I combine my numerators, I got negative 6, or is that positive 6? That would be positive 6. Positive 6i squared. So when I multiply those, positive 6 times negative 1, that's negative 6. And when I combine that with 8, I get positive 2 plus 16i. And then with the denominators, negative 4 times negative 1 is positive 4 plus 16 would be 20. So now when I separate this, I get 2 over 20 plus 16i over 20. This looks a little bit better. And when I reduce this, I get 1/10 plus 4i over 5, or 4/5 I. So once again, always a good idea to use your calculator to check yourself there. So when I work that out, that comes out to be the same as what we got when we did this in the calculator. So one of the things that we're going to look at sort of moving forward is some different things with adding and subtracting fractions involving complex numbers. And we'll also do some different things with multiplying square roots with values inside them that are negatives. And we're also going to get into looking at some different things in regards to the quadratic formula.